1 second. 1 second. See. LC oscillations. What is meaning of oscillation? Repetition of same thing is called oscillation. No? If I start from here, go to one extreme end, come here, go back, again come here. So can I say I'm following same path, going, coming, going, coming, going, coming, to and fro? That is called oscillation. Hello? Hello?
Yes,
Hello?
sir.
So LC oscillation is not displacement. There will be some electrical changes. Like suppose here there is device. It gives all its energy to this one. ये फिर इसको दिया, ये फिर इसको दिया, तो ये आना जाना सिलसिला चालू है ना, देगा लेगा देगा लेगा, ऐसा कुछ हो गया तो आई कैन से ऑसिलेशन.
Yes, sir.
What is formula for energy between the electric field of condenser? Three formulas we have: half CV square,
Half Q square by C and half QV.
so if I consider a condenser of capacity C to be charged with the help of battery of potential V. Let Q naught be total charge. If Q naught is total charge, what will be then energy stored between the plate when it is fully charged? When capacitor is completely charged, then energy, then electrical energy in the electric field between two plates of condenser, comma U equal to half Q naught upon C, half Q naught square upon C. Okay. Hello.
Yes, sir.
Yes, sir.
We just copy this much. Yes, completed.
Completed, sir.
ठीक है. That means if I have a condenser of capacity C and this is switch at position A connected to battery of voltage V, तो इधर प्लस प्लस आएगा, इधर माइनस माइनस आएगा, बराबर. हेलो.
Yes, sir.
When this is disconnected and connected to position B now, and this is inductor L, तो ये चार्ज किसको मिलेगा? इंडक्टर को मिलेगा ना पूरा ऐसे.
हाँ, sir.
So that means it will keep on discharging and that charge will come like this as shown here. See, this is condenser. After charging is disconnected from the battery. Now it will start supplying the charge to this in this direction. So if there is flow of current in this direction, there is some change in flux in this. There will be magnetic flux developed here across this, correct? No? Hello?
Yes, sir.
What magnetic flux will try? It will try to oppose this.
Yes.
So a stage will come when this will reduce to 0. तो वो टाइम पे ये फ्लक्स मैक्सिमम हो जाएगा. इसका पूरा चार्ज 0 जो भी है वो इसके पास है खाली एनर्जी. ये करंट 0 हो गया ना आई. ओके, नहीं समझाए. इसके इधर करंट गया गया गया, ये ओपोज कर रहा है ना उसको. तो पहला 10 गया, बाद में 9 गया, बाद में 8 गया, बाद में 7 6 5 4 3 2, एक टाइम पे 0 हो जाएगा ना करंट. तो तभी इस पे
Yes.
चार्ज नहीं. तो इसका अंदर फ्लक्स मैक्सिमम हो गया ना अभी इसका एनर्जी. तो ये पूरा एनर्जी किसको मिला? इंडक्टर को मिला कि नहीं?
मिला, सर.
कितना मिला? हाफ Li² मिल गया ना. एनर्जी ऑफ इंडक्टर कितना है? हाफ Li² है ना.
Yes, sir.
और कैपेसिटर का हाफ Q² अपॉन C हम लोग ने लिया. तो जब ये पूरा इसको दे दिया तो अभी इसके पास कुछ भी एनर्जी नहीं. तो ऑल एनर्जी बिकम्स व्हाट? मैग्नेटिक एनर्जी.
Yes.
बट ये बहुत देर तक रुकेगा नहीं क्योंकि इसको तो चेंज इन फ्लक्स का जरूरत है ना. ये इंडक्टर है, परमानेंट करंट जाता है कि इससे जब तक
नहीं.
फ्लक्स चेंज होता रहेगा तभी जाएगा ना.
हाँ.
तो जैसे एक बार करंट मैक्सिमम गया तो इसने एनर्जी स्टोर कर लिया मैक्सिमम. अब क्या करेगा ये? इट विल बिहेव लाइक बैटरी. क्या फॉर्मूला है? -LdI/dt है ना बैटरी का, ईएमएफ का. तो अभी इसका ये साइड प्लस हो जाएगा ना, ये वाला, और ये माइनस ना उल्टा होता है ना.
Yes, sir.
तो ऐसा हो गया तो क्या करेगा? वो करंट देगा ना फिर से कंडेंसर को. क्लॉकवाइज
Yes.
देगा कि एंटी क्लॉकवाइज देगा? In what direction it will give? Clock or
Sir,
anti?
anti.
This is condenser when it is fully getting charged. So this will start sending the current in this direction to this. I till इसका पूरा एनर्जी खत्म हो गया, बिकॉज इट विल बिहेव लाइक ऑपोजिंग. पहला ऐसा आ रहा था प्लस टू माइनस, तो अभी ऐसा जाएगा ना इसके अंदर से. तो हियर प्लस प्लस विल गेट डिपॉजिटेड and here there will be induction. Correct? No? Hello?
Yes,
Hello?
sir.
Yes, sir.
फिर से जब इसका एनर्जी जीरो, तो ये मैक्सिमम चार्ज हो गया. Now what will happen? Again it will supply current in this direction. तो फिर से ये जीरो हो जाएगा. आ रहा है ना समझ में? तो ये जीरो हो गया,
हाँ,
तो
सर.
इधर का प्लस इधर आ गया, माइनस इधर, तो बाद में ऐसा करंट देगा ना ये.
हाँ, सर.
तो फिर से प्लस हो गया, तो क्या देखा आपको, जैसा फर्स्ट था वैसे ही आ गया ना बाद में.
हाँ, सर.
तो जिसको ऑसिलेशन बोलते हैं ना, जिधर से स्टार्ट किया उधर ही आ गया.
Yes.
Not followed, I think, meaning. You all have followed the meaning?
So can you explain once more from D?
From D?
Yeah.
No, from A I have to explain you. From A means after being disconnected. Then you will understand now. This is battery. This is condenser. Condenser is connected to the battery. What will happen? It will get charged, na? This side plus and this side minus. Correct?
Yes, sir.
At that time, this was not connected. So in case one, battery is made fully charged. The condenser is fully charged and then disconnected. So when condenser is disconnected from the battery and made connected to the inductor, then it will discharge through the inductor by supplying current in direction as shown. Clear?
Yes, sir.
During this discharge, there will be magnetic flux developed here across inductor, which will try to oppose the current. So finally current will become zero, a stage will come, then all the magnetic field will be associated here. Now this will behave like battery with positive terminal here, negative terminal on the other side.
Yes,
बराबर
sir.
ना? तो जब इसका करंट पूरा जीरो हो गया, ये कंडेंसर का, तो उस पे चार्ज नहीं है ना, मतलब. तो ये जीरो चार्ज का हो गया. This entire charge went where? To develop the field. Now what will happen? This condenser will send the energy in opposite direction, from here positive to this plate. So current will start entering, so that here plus charge will get deposited. Till when? Till this current becomes zero, इसका खुद का. फिर बाद में क्या होएगा वापस? When this is plus, this is minus, magnetic energy becomes zero. Now current will move like this. So again this will get charged, but in opposite direction. Not followed.
Forward, sir.
Then when it is fully charged, फिर से ये current zero. जैसे ही current zero, अभी ऐसा current supply करेगा इसको, ये plus ये minus हो जाएगा, as shown in figure B. So thus we get same nature of charge developed. This is called oscillation. Maximum, zero, negative, again zero, back to the same. Correct?
Yes, sir.
So you have followed this concept first. खुद से भी लिख सकते अगर समझा तो. When the condenser is discharged through the inductor, then the current will go through the inductor and magnetic flux will be developed, which will oppose the current flowing through the condenser. A stage will come when current through the condenser becomes zero, charge becomes zero, as shown in figure C. Now the battery will supply the current to the opposite plate of the condenser, making it charge oppositely till current of the magnetic field becomes zero. As soon as condenser becomes maximum charge in opposite direction, again it will start discharging current in the coil, which will again gain magnetic flux, and the condenser will become zero. When condenser becomes zero, again inductor becomes maximum and supplies current in opposite direction. Hello?
Yes, sir.
तो हो गया ना लॉजिक, समझा क्या नहीं पहले ये बता।
Yes, sir. Yes, sir.
पहले क्या हो गया, इसने दिया इसको
Inductor. Yes, sir.
और ये जीरो हो गया। अभी क्या हो गया, जब ये
Inductor
मैक्सिमम
gave.
हो गया
Yeah.
तो ये फिर से इसको दिया उल्टा डायरेक्शन। तो पहला इधर प्लस, फिर कुछ नहीं, फिर उल्टा प्लस, फिर कुछ नहीं, फिर वापस सेम डायरेक्शन में आ गया ना। सो इट इज लाइक व्हाट, मैक्सिमम
Oscillation. Yeah.
जीरो
Oscillation, sir.
नेगेटिव जीरो बैक टू मैक्सिमम, ऑसिलेशन ना देन
Yes, sir.
मींस मैक्सिमम जीरो नेगेटिव जीरो बैक टू मैक्सिमम। व्हाट इज
Maximum.
दैट कॉल्ड, ऑसिलेशन ना।
Oscillation.
Yes, sir.
इसको इलेक्ट्रिकल ऑसिलेशन बोलते हैं। कितना सिंपल है।
Yes, sir.
चलो अभी डायग्राम बना लो, पूरा समझा तो ही आगे जाता हूँ। समझा बराबर?
Yes, sir.
ठीक है, I'm drawing diagram now for you one by one. First one, when battery is charging the capacitor, left side plate positive because it is connected to positive terminal of the battery, and this is inductor not connected, kept open. A. In B, when we disconnect the battery and connect inductor, then current will flow through this till magnetic field starts developing and net charge becomes zero. So here there will be magnetic field produced. In inductor, no charge. As soon as no charge, this will behave like battery. Then it will send again current from positive to negative. So this will getting charged and this will be induced this way till this current becomes zero. So finally, this will become maximum. This will become zero current here for one instant. Now, when this is zero, this is higher. So this will start sending current in opposite direction. Till this entire current becomes zero. Till this becomes zero. Now again magnetic field is developed, but this side plus and this side minus, and this becomes zero. G I am drawing here. Finally, this will start sending current in this direction. So this will get positive negative till this current becomes zero. So this process will continue. Correct now? Hello?
Yes, sir.
Yes, sir.
Draw this. So first it is giving the current in clock, gets discharged, then condenser sends the current in same direction but positive to the left hand side, right hand side plate, and finally becomes zero. Then this condenser again sends the charge. So again becomes zero. This time it gives ulta and as shown in G. Draw both all diagram A, B, C, D, E, F, G. Once you complete the diagram, tell, then we will do a writing part. Can I clear the diagram?
Yes, sir.
Okay. When charging battery is disconnected as shown in figure B, then capacitor discharges through inductor and magnetic field is produced across inductor till capacitor discharges completely as shown in figure C. Right now, when change in flux across inductor becomes maximum due to induced EMF in opposite direction, it supplies current to other plate of condenser, making it positively charged as shown in figure D. Copy. Once you are done, then tell. Huh?
Done, sir.
Okay. Thus, it is found that electric energy gets converted into magnetic energy in LC oscillations. It's converted into magnetic energy converted to magnetic energy, and the plates of condenser gets same polarity. This process continues. This is called as LC oscillations. Therefore, in LC oscillations, half Li square equal to half CV square. Okay. Completed?
Completed, sir.
Okay. Now, as per that planner, we have to do remaining sums of our classwork sheet, which is given as homework. Correct?
Yes.
Just open that. Last class I did. How many I did? I think I did 63, 64, 65 for you all.
Sir, we did actually did till 67.
67 भी हो गया. Okay. 68 now. Oh, sorry. 68. The rate of change of current is 500 ampere second raised to -1. second raised to minus 1. At instant key is pressed as shown in the circuit. So key is pressed in the circuit, then current is changing at the rate of 500 per second. 55 ohm, 100 milliampere. Then current through the circuit is how much? Resistance find it, current through the circuit will be how much? This change in flux will produce what? Induced EMF, which is minus L di by dt, correct? Hello?
Yes, sir.
So minus of L is 100 millihenry, so 10 raised to minus 3, and current is changing at the rate of 500. 1, 2, 3, 4. Minus 5 into 10 raised to 4 into 10 raised to minus 3. That means minus 50. Hello? Minus 50 volt.
Yes, sir.
It will oppose the change. So ulta it will be. So total EMF will become 60 minus of minus 50. That means it will be 60 plus 50. Can I say 110? Followed?
Followed, sir.
So total current I is total voltage upon resistance, 110 upon 55 equal to 2 ampere. Though. Shall I go ahead?
Yes, sir.
69. Two conducting circular loop of radius R1, R2 are in the same plane with their centers coinciding. Same plane, center coinciding, R1 and R2. The mutual inductance M between them will be directly proportional to what? Two conducting circular loop of radius R1, R2 with center coinciding, and they are in the same plane, then the mutual inductance M1 between them will be directly proportional to. Draw the diagram. Good sum it is. Can I clear? Oh, sorry, no diagram. This much written. So mutual means एक में करंट पास होएगा और दूसरे में कुछ तो इंड्यूस्ड होएगा ना. हेलो, म्यूचुअल मीन्स व्हाट? एक में पास होएगा और दूसरे में आएगा ना. हेलो.
Yes, sir.
So if I say let current I passes through outer loop. So what is flux developed? B into A. Flux is B into A associated with second coil. Hello.
Yes, sir.
Current I passes through the coil because we want mutual. R1, R2 are in the same plane. R1 is greater there given. So R1, R2. So field will be mu naught I upon 2 R1. Correct? No? Due to outer, which will get associated with the inner one, which is pi R2 square. Now what is flux formula? Is it M into current I? Flux formula is M into current I.
Yes, sir.
So if I compare, I will get Mi is mu naught I upon 2R into pi R2 square.
Yes, sir.
Can we cancel II? So
Yes.
M will become mu naught pi upon 2 R2 square upon R1. Therefore, M is proportional to R2 square upon R1. R2 square upon R1. Where it is given?
D option.
D option. Mark it. Very important sum. एक बार किया रहेगा तो ही जमने वाला है एग्जाम में. Done. Can we go ahead? Yeah. Can I clear 69?
Yes, ma'am.
Next some 70. A magnet is suspended lengthwise from a spring lengthwise. I say suspend yes by a spring. While it oscillates, the magnet moves in and out of coil C. Suspended lengthwise from a spring. While it oscillates, magnet moves in and out of coil C. In and out of coil C. इन एंड आउट मतलब ऐसा ऑसिलेट हो रहा है ना, in and out of coil C, because it will oscillate up and down. The magnet moves in and out of the coil C connected to the galvanometer. There is galvanometer connected here. Then as the magnet oscillates, okay, G will show no deflection, wrong. G will show deflection on one side, also wrong. It will show the deflection to the left and right and has constant amplitude. Constant amplitude बराबर है. Left and right जरा देख लेते क्या होगा. See, when it is moving at constant rate, so field will increase and field will decrease, na, at constant rate. This line clear? Field will increase, decrease in constant rate, correct? Hello?
Yes, sir.
That means first when it comes out, magnet moves inside. Moves inside. Then field associated is increasing or decreasing? Increasing, correct? Hello? Field is
Yes, sir.
increasing. Now induced current should give opposing field, correct na?
Yes.
So if field is coming upward, then current is what? Anti-clockwise, no? That is, it should be upward. अपवर्ड आना चाहिए ना फील्ड ऐसा, तो इसको अपोज करेगा ना इसका फील्ड को. हेलो, सो करंट इज इन एंटी क्लॉकवाइज, तो करंट एंटी क्लॉकवाइज जाएगा तो इसको लेफ्ट में शिफ्ट करेगा ना. करंट इज इन एंटी क्लॉकवाइज, समझा?
Yes,
करंट
sir.
एंटी क्लॉकवाइज, फील्ड विल बी अपवर्ड. अपवर्ड मींस डाउनवर्ड वाले को अपोज करेगा. Therefore galvanometer will show deflection where, left or right? Where it will show? This is galvanometer connected. ये करंट ऐसा
Left,
जा रहा है एंटी क्लॉकवाइज, तो इसको लेफ्ट में
left, yeah.
will show
Left.
deflection in left. तो ये आंसर है ऑप्शन सी. G to the left and then right. C is option. Direction base is important because you can't have any formula. You have to just understand. If you have understood, you can predict perfect results. Done. Then can I take 71 now?
Yes, sir.
Okay. 71. The network shown in the figure is a part of complete circuit. This is network. 15 volt, 1 ohm, A, B, 5 millihenry. Current is going. The current is going from A to B is of 5 ampere. Then what is VB minus OPA? Okay. How much will be EMF induced here? Minus L di by dt. Correct, na? So minus 5 into 10 raised to minus 3. Current is changing at the rate 10 raised to 3. Minus 5 volt will be induced here, but in opposite direction of the current. So here plus and here minus. Now if I start by Kirchhoff's voltage law, so VA minus 5 into 1 is the voltage, minus plus is plus 15, minus to plus 5 equal to VB. This will get cancelled. Therefore VB minus VA is 15. Option B. Done 71.
Yes, sir.
Okay. 74. A closed loop is lying in XY plane. A loop is lying in XY plane. Carries current if uniform field B is present in the region. Force acting on the loop will be zero if B is in which direction? Line carries a current if uniform field B is present in the region. Force acting on the loop will be zero if field is in which direction? अभी करंट क्लॉक और एंटी दिया नहीं है ना, चेक करता हूँ बराबर दिया है क्या. Force acting on the loop will be zero if P is in which direction? Today we stop here. This clock NT I will find out, then we will do. Otherwise 2 options we have to complete. So that's all for today. Please stick to the planner as I have told. Keep on practicing on daily